Okay, so we're going to actually take a look and figure out how we are going to be able to use combinations when we find the probability of an event. Let's see, Whistler's Mother, Edvard Munch's The Screen, Mona Lisa, American Gothic. I think we got the wrong artwork up here. Ah, playing cards, a deck of cards, that's better, but let's get a little classier than a bunch of dogs. There we go. Now our friends from before have joined, and now we have a bona fide artistic classic photo. Okay, now the reason why I want to use the deck of cards, it's a great visual aid for when we're doing probability. And I gotta warn you, this first example I do is gonna take forever, but then we'll do a second and a third example, and those will go real quick. So you say, oh, I can do the assignment. But I want to go through this first example really, really slowly so you understand why it is working. And it's just a lot easier to visualize a deck of cards than say, hey, look, I got 52 Zablotniks here. Or, hey, let's make up 52 flavors of ice cream. Right? So deck of cards, if you're not real familiar with those, there's a graphic. There are 4 suits. And so from top to bottom here, it's diamonds, clubs, hearts, spades. And there are 13 cards in each suit, starting with ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And so there's 52 cards altogether, right? 13 times 4 is 52. And we could do some easy probability with a deck of cards. I could say, hey, let's draw 1 card at random. What's the probability that's red? Well, 26 of the cards are red. There are 52 cards, so 1/2. What's the probability that if I take 1 card at random, it's a club? Well, 13 of the cards are clubs. 52 grand total, 13 over 52, 1/4. What's the probability that if I just grab 1 card, it happens to be a 2? Well, there are 4 different 2s in that deck. There are 52 cards. 4 over 52 reduces to 1/13. So we could do some real basic, easy probability, but I don't see the need to use permutations or even more exciting combinations here. So let's say instead we go back to our poker tournament here, or maybe I'm even watching a poker tournament on television. And there's a deck of cards, and we shuffle it up really, really well, and we do a fair deal everywhere. And each player gets 5 cards in this game. And I'm rooting for the Scream, right? That character from Edvard Munch's drawing there, the Scream. And I want him to get exactly 2 aces, right? Or maybe he gets dealt exactly 2 aces. I'm like, wow, all right. He was dealt 5 cards, exactly 2 aces. What's the probability of this happening? Now, we've been doing so much work with permutations and combinations, we've gotten a little bit away from probability. So we got to remember, it's the number of favorable outcomes in the numerator, the number of possible outcomes in the denominator. Okay, now let's move that to the top of the screen. What are the number of possible outcomes? Now remember, we're being dealt 5 cards. I want 2 of them be aces, and 3 of them are not aces. How do I go about this? Oh, this is like ice cream in the bowl, right? I need the combinations. And so, not a permutation, but a combination, because the order doesn't matter. I don't care what order these cards come in. I just need 5 of them. So the easier part of this is the denominator, right? There are 52 cards. I need to be dealt 5 of them. I don't care about the order. Oh boy, you're going to hate me by the time I get through this, right? So in the numerator, I don't want to write this all the way out, right? 52 times 51 times 50 times 49 times 40, right? It keeps going all the way down to times 3 times 2 times 1. Then in the denominator, I got 47 times 46 times 45, blah, blah, it keeps going all the way down to 3 times 2 times 1. And then I've got the 5 factorial, which is 5 times 4 times 3 times 2 times 1. Now, mercifully, a whole lot of the numerator cancels with a whole lot of the denominator. But what I'm left with doesn't look that easy. I'm like, oh, man. So I'm going to scratch my head and say, hey, you know what? The 50 I'm going to change into 5 times 10. The 48 I'm going to change into 2 times 24. Because in the denominator, if I take the 4 times 3 times 2 times 1, that's 24. And I can do some reducing. Oh, but I mean, I'm still left with a big mess. I'm like, there's got to be a better way of doing this, right? I mean, look at that number, 2,598,960. And all I've done so far is I've just figured out the possible outcomes, right? I've only figured out the denominator, right? That's how many different ways I can get dealt 5 cards out of that deck. So I've got the bottom of the fraction. I don't have the top. Hey, there's look at that screenshot from my calculator. What are those white blotches hiding? Oh, my calculator will do combinations for me. I don't have to do them by hand. I can have the calculator do them for me. Okay, so we're going to come back to this example and finish it in a moment, but I want to talk about some calculators for a moment. All right, so this is where we were. We say, hey, possible outcomes. I need to do the combination of 52, take 5. Now, if I'm using like a TI-84, I have to find the math menu. I just highlighted that in yellow. When I go into the math menu, it automatically starts right here. I need to move over to PRB, that's probability. And when I get over to PRB for probability, if I look down the list, I see an NCR. I go, aha, there it is, that's combinations. Now, the tricky thing with these TI-84s is to actually type this thing in. I would first type in my 52, then I'd go to that menu and I'd find my NCR, then I would type in the 5, then I could hit enter, and sure enough the calculator says, yeah, 2 million blah 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 blah. Okay. Now of course not everybody has a TI-84. If you've got a, where'd it go here, TI-89, this is a real tricky one to try to find the math menu, right? It's a secondary feature and it's microscopic almost to try to find that math menu. And when I get into the math menu, I can select probability and then I can select combinations. Now the nice thing about the TI-89 is that I actually get to type it in the way I've been doing it with pencil and paper. I say, oh yeah, I want the number of combinations, 52 items taken 5 at a time. And I can actually type it in that way. Ugh. Now, most user-friendly of the bunch, this is an online calculator that is available through Desmos, and I'm going to have the website. If I remember, the website will be in your email and on Quick Schools. But if I go to the function menu, I can find the combinations, and I can just type it in and say, hey, the number of combinations, if I've got 52 items, I take 5 at a time. And of course, it'll pop out the answer for me. And the website's real simple. It's just desmos.com/scientific. But I will put that link at Quick Schools, and that link should also be in the email you receive. So if you say, hey, you know what, that calculator looks easier than anything else, right? You can get on the Desmos. Just got to make sure that you hit the function tab, right? Because it won't come up looking like this. Yeah, I have to actually hit that function. But then you can do the combinations with very, very little effort, and you don't have to hunt and search like on a scientific calculator. Okay, so where were we? Okay, we found the denominator. Now we got to go after the numerator, so the number of favorable outcomes. Okay, now I want 2 aces, but there are 4 in the deck. Let's get a visual up here again, right? That's what my entire deck of cards looks like. There are 4 aces, and I need exactly 2 of the aces. Now, of course, if there are 4 aces, there are 48 cards that are not aces. That'll come into play in just a moment here. All right, because I'm looking at aces and not aces. 4 aces, 48 not aces. Okay, so if I need 2 of those 4 aces, well, again, it's a combination. This one's not so horrible, so I could do it by hand if I wanted to, although I'd be very tempted instead to say, no, I'm going to grab a calculator. But now that I've got 2 cards that are aces, I need 3 cards that are not. And again, a moment ago I said, hey, there are 48 cards that are not aces. This I do not want to do by hand, right? 48 items taken 3 at a time. How many combinations? I want to go straight to a calculator and say, hey, calculator, please give me a number. Right? And so there we have our number. So I got to think about the number of ways I can get 2 aces, the number of ways I could get the 3 not aces, and the total number of possibilities. Then I am going to actually have to multiply those, right? So I actually have to take the 6 that I got for the aces times the 17,296 that I got from the not aces, multiply those together, and that's my numerator. Now, normally, I would say, hey, let's reduce the fraction, not when the numbers get this insanely large, right? I mean, the denominator is over 2 million, right? So I'm going to grab a calculator, and I'll say, okay, it's about 0.0399, right? I usually do, 3, 4 decimal places. And then I might say, oh, it's pretty close to 4%, right? So not very likely that I'll get it dealt exactly 2 aces. Okay, now at this point, you're like, this is going to take forever. So let's do one more example with that deck of cards, but just look at how quickly we can actually get through this. So here's a brand new example with a deck of cards, and then we'll do an example that has nothing to do with the deck of cards, okay? So let's pretend I'm playing blackjack, different card game, and I get dealt exactly 2 cards. I want a score of 21. That's what they call blackjack when you score 21. So I need 1 ace, and then I need 1 card with a value of 10. Now, if you're not into playing cards, the cards that have a value of 10 are the 10, jack, queen, and king. And then if you're trying to figure out how on earth could this possibly add up to 21, because wouldn't 1 plus 10 add up to 11? Well, the ace can also be used as an 11, okay? It's a crazy game. But the key here is I need 1 ace, I need 1 of those cards that's either a 10, jack, queen, or king, and I'm only going to get dealt 2 cards. So find the probability of being dealt a score of 21. Okay, again, here's my deck of cards. I've got to have an ace. There are 4 of those. And then I've got to have either a 10 or a jack or a queen or a king. Right? So there's 16 cards that are okay for that. So let's find the probability. What's the probability of getting a blackjack or a score of 21? Well, for the aces, there are 4 aces. I need 1 of them. For the cards that have a value of 10, there are 16 of them, and I want 1. Because from that entire pile of 52 cards, I'm only going to get 2 of them. And again, I would go straight to the calculator. I say, calculator, please provide me some numbers. So I know that the probability of getting a blackjack would be 4 times 16 divided by 1,326. Again, I just grab a calculator and I say, hey, this is about 5%, right? It's pretty close to 0.05, so about 5%, not very likely. Okay, so let's pretend you're not into playing poker or blackjack, you're not into cards. Come up with another example. And again, I need kind of like a large sample space. So let's go back to letters of the alphabet. Let's pretend I'm playing some type of word game. And let's pretend there are 26 tiles, exactly one for each letter of the alphabet. Right? The tiles are upside down, they're mixed around, so I don't know which one is which. And let's pretend I grab 8 tiles at random. What is the probability that exactly 2 of the tiles have a vowel, right? So there's 26 tiles, one for each letter of the alphabet. I randomly select 8 without having any idea what they are. And I'm wondering what's the probability that exactly 2 of those 8 happen to be a vowel. And again, we're going to assume that for vowels, we're just going to use A, E, I, O, U. Okay, well, let's find the probability that I get 2 vowels on my tiles I'm going to use. First of all, well, the vowels. There are 5 vowels, and I want 2 of them. Okay, how about the non-vowels? Well, there are 21 vowels. I'm sorry, there are 21 consonants, right? 21 letters that are not vowels. And I need 6 more to complete my pile of tiles here, right? If 2 of the tiles are vowels, 6 of them are not vowels. And of course, there were a total of 26 tiles, and I have 8 of them. So there is our probability. Again, I go straight to the calculator. A little bit tricky, I gotta make sure I'm typing things in the correct order. And I've got 10 times 54,264 over 1,562,275. And you're thinking, well, gee, what's this going to be? Actually, probability is not that bad, about 35%. Right? If you think about it, say, hey, if I got 8 letters, chance of 2 of them being a vowel, not that horrible. Right? It's not like you're saying, hey, I'm playing with this huge deck of cards and I need exactly these 2 cards or something, right? So, right, the percentages kind of bounce around. But your calculator would be a friend, whether it's your handheld one. I would recommend the one off of Desmo's just for ease of typing the stuff in. And worksheet looks like it has been crafted out of some rusty steel here. There we go. Rusty old vehicle. And again, that first example was kind of a long one, but that second and third example probably give you a better idea of how to attack this.